Hello there, everybody, and welcome you ROS developers to a new open class. Today we have open class number 138, and we are going to be talking about a very important topic related to ROS2, which is quality of service. It's a new feature that has been introduced in ROS2, and so we are going to be checking a little bit what this is and trying different configurations and seeing how this can affect our ROS2 nodes. So welcome everybody. Then first of all, please let me know if everything is all right, if image is okay, also audio, if you can hear me properly. So I'm not going to lose any more time. Then I'm going to switch directly to my screen so that I can start checking your messages in the chat and everything. So let's go for it. All right, then I'm going to directly log in and make sure that everything is working. So you are now in this workshop section. All right, so I can see that the stream is working properly. At least I can see there Marco saying hello. Also Jose, who says that image and sound are perfect. Okay, great. Then so as always, the first thing that I want you to do and that you have to do is to get the rosject related to today's open class. So in order to do this, you have to click on this button that appears here on top of the chat, which says fork and open the class rosject. So I'm going to click here myself right now. And this is going to automatically copy the rosject. All right. This is going to automatically copy the rosject that we are going to be using today into your workspace. So you are going to have this rosject forever. You are going to be able to access it and open it whenever you want. And it's also going to automatically open it, as you can see. So I have been redirected here to the rosject page. And so my rosject is being loaded here. And also I have in this right side the streaming panel with the live stream, also the chat here, so that you can ask questions and interact with me. Mine is already being loaded. As you can see, the notebook is opened automatically. So make sure that you have the proper notebook, which is this one, the one for open class number 138. And I'm going to take some minutes to make sure that all of you have the rosject and that you can open it and access it properly. So let me know in the chat, have you been able to open the rosject? Do you have already everything loaded with the notebook and everything? Yes, no? So as always, let me repeat it one more time. I want you to have the rosject opened, because I want you to be practicing with me, okay? So these open classes are interactive classes, so they are not meant to just be teaching and showing things and all of you just be listening there and watching to what I am seeing, but they are interactive instead. All right, so I'm going to be doing, I'm going to be explaining things, of course, but I'm going also to be doing some practical demonstrations. And of course, you are able to do them and you should do them with me. All right, so everything that I'm going to be doing, you can reproduce it in your rosject, in your workspace, so please go ahead. I can see here Jose says yes, Leone also says hello, everything fine. All right, then let's get started, right? So as I was saying, today we are going to be talking about quality of service in ROS2, and we are going to be doing some demonstrations and seeing how we can configure these QoS settings for our ROS2 nodes. But before that, we are going to be launching our simulation, as always. So let's open a new web shell, which is the first icon that we have down here. If you click here, this is going to open a new terminal, which is just a regular Linux Ubuntu terminal, where you can type all kind of commands here. Then so here you have the commands, that you need to execute in order to start the simulation. So you can copy them directly here from the notebook, like I am doing here. You can copy them directly from here or with the shortcut Control-C, whatever you want, and then you can paste them here. All right, I'm going to do this with the two commands. And this is going to start the gazebo simulation. In this case, this gazebo simulation is based in ROS2. So we are going to be working with quality of service, which is a feature, and let's call it a feature, yeah, that has been introduced in ROS2. So this is not available in ROS1. So we need to be working on ROS2. So that's why I am starting here a ROS2 based simulation. Then, yeah, so this command is going to start executing things, as you can see. You might see some yellow and even red commands. Don't worry, okay, nothing to worry about. And this is going to automatically open here a simulation, a gazebo simulation, as you can see. Here I have it loaded, all right? In my case, everything has loaded perfectly. So in case that yours doesn't load, so sometimes the first time you run gazebo, it might give some errors due to times, okay, time limits when loading things. But yeah, in case that this doesn't work properly, or you don't have the robot or something like this, just Control-C the command here and launch it again. Okay, so let me know, have you been able to load properly this simulation? Do you have it? So you should see something like this with robot here in the center and which is here loaded in a world. All right, so let me know. Have you been able to load the gazebo simulation properly? Yes, no. I see the simulation environment, but without robot nor objects. Okay, Jose, then in case that you are having this problem, I'm going to do it also myself, all right? Let's Control-C. I'm going to cancel the command here. Let me Control-C here. So yeah, this something, sometimes it happens due to timeout, okay? Then in that case, just yeah, Control-C, terminate the command and run it again. And very likely it's going to get solved the second time that you execute it. All right, yeah, make sure that you have the robot here. So we are not going to be interacting a lot with the robot now, but we are going to be using it in order to check one of the topics, in this case the laser topic. So we need to have the simulation running for later on the class. So yeah, did this solve the issue, Jose? Can you see the robot now? Only a blank screen. Maybe you are zoomed. You have zoomed a lot, Jose, and you only see. Or can you see the client or? Okay, now it's fine. All right, perfect. Perfect, Jose. All right, then, yeah, so once, now that we are all set up, let's go with it and let's start with the class itself. So yeah, quality of service. What are they? What is this quality of service? So, as I was saying at the beginning, this is a new concept which comes and has been introduced into ROS2 and comes by the hand of the DDS, all right, the Data Distributed System, which we are not going to be covering today. But in case that you want to revisit and learn a little bit more about this, we have another open class that we did some months ago, where we are... Let me mute this, where we are talking about DDS, right? Let me find it here. If you scroll down, if you come to workshops and scroll down, you're going to find it. All right, it's, let me see if I can see it. It's been already some class here. Yeah, so here we have it. All right, understanding DDS in ROS2. So you can have a look at this open class if you want in order to better understand what this DDS. But basically, this is a summarizing. This is a new concept that has been introduced into ROS2. Okay, it's a kind of middleware which connects some communication protocols, data distribution systems with ROS. Okay, so in ROS1 we didn't have this because we had a custom middleware, which was this ROS1 TCP, which was used for transporting messages. Okay, in ROS2 what we have is a kind of middleware that we put in between the ROS2 system and the protocols for transporting messages. Okay, which can be many on the regular industrial standards like Cyclone DDS, Fast RTPS. There are some of them which are currently supported. Okay, you can also implement your own. But yeah, so this DDS concept has also introduced with it this quality of service. So basically, what this allows us, quality of service allows us to tune and customize and have a much higher control over how we want our messages, how the messages are going to be transported, all right, between our nodes. So this is very useful, especially for critical systems, real-time systems, these were some of the problems that ROS1 had. Okay, then with this quality of service, we can improve a lot the performance of our nodes and of our transport of messages in our systems. All right, then. So this can be used in any kind of ROS2 node. For instance, the most common ones are publishers and subscribers. But this can also be used for services, also for actions. We are not going to be covering this, however. We are going to be having a look at how to configure these QoS settings, this quality of service, for publishers and subscribers. All right? Then how can we change, how can we customize these QoS settings? And we are going to be checking also in this section too about the QoS compatibility. All right, so there is an important concept related to QoS, which is that the QoS settings of two nodes have to be compatible between them. If they are not compatible, then the messages are not going to be shared properly. All right, so we are going to do a demonstration, an exercise. We are going to do some practice in order to better understand this concept of QoS compatibility, and also we are going to see how we can access and configure these QoS settings in our nodes. So let's start. Then, first of all, we are going to create a new package where we are going to be putting all our code for today's open class. So yeah, let me open a new shell. You can open a new shell, a new terminal by clicking here in the plus button. So this is going to open a new shell, as you are going to see right now. Here I have it. Then here I'm going to run this command. Well, not here. Okay, so I'm going to create my package inside the ROS2 workspace SRC folder. Okay. Then, in order to have a better understanding of and have access to this ROS2 workspace in a graphical way, which is always easier to deal with than from the terminal, we are going to open the code editor, which is this second icon that we have here. So, if you click here, this is going to open the integrated development environment, which is going to give us access to all the workspaces and all the files that we have here in our rosject in a graphical way, which is always easier to deal with, right? Then in this case, we are going to be placing our package, as you can see here, in the ROS2 workspace. Okay, specifically, we have to create and add our new package inside the SRC folder of the workspace. So once you navigate to this SRC folder of the ROS2 workspace, here we can execute our command, our ROS2 package create command, in order to create the new ROS2 package. So let me run this command right now, and this is going to create, as you can see here, a new package, QoS_tests_package. All right. Then let's for now create two new files. We are going to create two new Python scripts. One is going to be named like this, publisher DDS custom QoS.py. So let me get the exact name from here. And then we have to create these new Python scripts in this folder, this QoS test package folder, okay? Not the first one, which is the package, but inside this other folder. All right, you are going to see that this folder contains also a init.py file. Then here is where we are going to create our new Python scripts. There it goes, the first one, the publisher, and we are also going to create another one for the subscriber. Let me copy the name, create new file. There we go. All right, so you are going to have your package with two new Python scripts here, which right now are empty, but we are going to be filling them in a moment. So yeah, here you have the code for the subscriber Python script. So you can directly copy it from here. Let's do this right now and paste it, okay? And we are going to do the same for the publisher. You have if you scroll a little bit down, you are going to find also the code for the publisher. So let's select and copy all the code and paste it. Copy and paste into the publisher. Yeah. Okay. Now, in a moment, we are going to come back here to these scripts, and we are going to be checking line by line what they are doing. All right. For now, let's just keep going. So we are going to generate executables. Next step is to generate the executables for these Python scripts so that we can run them. So for this, we have to come here to the setup.py file. And here in the entry points, we are going to add these two lines that you can see here. Okay, so let me select them as well from here. Control C. And Control B. There we go. Okay, so here basically we are generating these executables. Okay, this is the name of the executable. This is the name of the folder where our Python script is contained, which is this one. Then this is the name of the Python script itself. Yeah, publisher custom minimal QoS. Which, by the way, I can see that the name is not correct. Oh yeah, so the names of the files here are wrong. Okay, I didn't notice this. So yeah, here we have the names. Okay, the names that are stated here in the notebook are wrong. Okay, here they are named publisher DDS custom QoS and subscriber DDS custom minimal QoS, whatever. These names are wrong. Okay, the correct names are the ones that appear here. So let me rename my files. It's very simple. Don't worry. Okay, don't panic. Let's get the name here from here, and let's rename them. So if we right click here on the file, we have an option which is rename. Okay, so here we can introduce the name of the file. There we go. Subscriber custom minimal QoS. And the same for the publisher. So let's grab the name from here and rename it. Rename There we go. Okay, so now the names are correct. See? So how did I spot this error? Because the name of the Python script has to be the same as the one that we have here. Okay, and so the names in this case were not the same. So I know that there is an error there. Okay, so now yes, now the names are matching the ones of my file. So I have publisher custom minimal QoS and subscriber custom minimal QoS. All right. So yeah, make sure that you add these two lines here to your entry points in order to generate the executables. And now we are ready to compile. So once we have created our scripts, we have updated our setup.py file, we can compile. So let's come to the shell. Let's go to the root of our workspace, home/user/ROS2 workspace. And here we can run the callcombuild command in order to compile. Okay, callcombuild. There we go. This is compiling my package. In this case, it's compiling this, well, the only package that I have in my workspace currently. So yeah, compilation has finished successfully. Very important after compilation to source our workspace. All right, with the command source install setup.bash. You have also the command here. Very important to run it. And there we go. All right, so we have created our package. We have created also two Python scripts, one for a publisher node and another one for a subscriber node. And then we have generated the executables and we have compiled our package. So we are ready to run our nodes. Okay? Then, before actually running them, let's have a look, all right, at the scripts. Let's have a look at the scripts and let's find out or figure out, first of all, understand what's going on here and figure out what is the expected behavior of our nodes. All right? Then let's start, for instance, by the publisher, okay, which is a little bit more complex in this case. So what are we doing here? Okay. Well, first of all, we have several, we are importing several modules like RCLPy, node, string, message, some QoS related modules as well for profile, for the durability. These are some specific settings. We are going to learn a little bit more on all these more specific things later, all right? So, we are basically importing some QoS related modules, some messages, and things that we are going to be using in our node, all right? So, here we are defining our class, which we are naming publisher QoS, and as you can see, it inherits from the node parent class. And then here we have the constructor, which is expecting to receive two items, two arguments. The first one is a variable named QoS Profile. So whenever I create an object of this class, I'm going to need to specify this QoS Profile. Whenever I call the constructor of this class, and also a node name, which by default is going to be publisher QoS object. All right. Then so we are initiating our node here. As you can see, we are getting the name from the argument. We are so here we are just setting the logging level for the messages that I want to see from my node. We are setting it to info. Then very interesting line here. So here I am defining a callback. All right. In this case, this callback is a publisher event callback. So I am defining here a callback which is going to trigger on the event of incompatible QoS. Okay, so publishers can have different type of events. One of them is incompatible QoS. Then if this event is triggered in my publisher node, which is this one, I'm going to be calling this callback function. Okay, this callback function I have defined it down here. All right, we are going to see it in a moment. Well, actually, it's very simple, so we can just have a look now. As you can see, this callback function, all it is doing is to print some messages. It's printing a message here which says, hey, a subscriber is asking for an incompatible QoS triggered. And then I am printing here the last policy kind. Okay, so I am printing some information, but inside this callback, I could do whatever I want. Okay, and this callback is going to be triggered, so it's going to be called on the incompatible QoS event of my publisher node. All right. Then I am defining my publisher. As you can see, I am creating my publisher. I indicate the message type that my publisher is going to be using for his messages. I define the name of the topic. I define also a QoS profile, which I am getting from this argument here. All right. So the argument that I'm going to receive here, whenever I create an element of this class, this QoS profile element that I'm going to be receiving is the one that I am going to use in order to set the QoS profile. All right. And then finally, I also define as event callbacks the callback that I have just defined right here. All right. Okay. Then I am just defining some variables here. Messages ID, current time in seconds, current time in nanoseconds, a timer period, and then I am creating as well here a timer object. Right? Create timer with the period of 0.5 seconds. And of course, I have to define also a callback associated to this timer. Then what I am doing in this timer callback? Let's have a look. So this timer callback is implemented down here. Then here I am just defining a message, which is going to be a string. Then I am populating this message. In this case, here I'm going to be populating this message with some time values. Okay. So as you can see, I'm getting the current clock time. Yeah. Then I am getting the value of this time in seconds, the value of this time in nanoseconds, and then I am generating here a message with an ID and the time. Okay, so basically I'm just populating a message with some values. In this case, are just the current time in seconds, in nanoseconds. Okay, this can be anything you want. All right, so yeah, here I am just doing this, but you can do whatever you want here. Then yeah, so once I have created my message, I have populated my string message, then I publish it. All right, so I'm going to be publishing my message into the QoS test topic. All right, then yeah, so okay. So far, are you following more or less? Any doubts on something here of this first part of the code? Something that you don't understand? Any question? Something is not clear? Good for now, says Jose. Okay, then let's keep going. All right. So yeah, so here until here it finishes the class definition. Okay. Now, oops. Yeah. So you can minimize it here so that these you see that are different things. Okay. So far I have the constructor of my publisher QoS class with the callback function incompatible QoS callback, which is going to be triggered on the incompatible QoS event that we are going to see in a moment what this event is. And we have also the callback for our timer. All right. So yeah, let me minimize this. Then we have a function which is called GetParser. Okay, what is this function doing? Well, this function, as you can see, it's adding an argument named reliability, okay, which has two possible values, two possible choices. It can be either best effort or reliable, okay? So I am adding this argument to my node, okay? So whenever I run my node, I'm going to have to define this reliability argument. Okay, I'm going to have to specify a value for this reliability argument. Okay, and the value has to be either best effort or reliable. Okay, then finally, what do I have here? I have the main function of my script. Okay, this main function, as you can see, it's calling the GetParser function, first of all, and it's getting the arguments that we have parsed from here. Then I am printing the value of reliability, and then I create a QoS Profile object. Okay? This is a QoS profile where I'm going to be able to set all the QoS related settings. Then, so for instance, here I am setting the durability. I am setting the durability to volatile. Here I am setting a deadline. Here I am setting liveliness. All these specific settings we are going to see later what they mean. Okay. For now, just see in the code how they are being set. How I am changing and I am specifying the QoS settings. Okay, the different QoS settings for durability, deadline, liveliness, and here is where I am setting the reliability value. Okay, as you can see, I am checking if the value in this case is reliable, then I am going to set it to reliable. If not, then I am going to set it to best effort. Okay? All right, then, so finally, I am just initiating my node, and I am calling my class here. Yeah, I am instantiating my class, and as you can see, I am sending the QoS profile that I have been defining here. I am sending it to the constructor of my class. Yeah, so this object, this QoS profile object that I have been defining here, I am sending it to my class so that it's going to be received here in this QoS profile argument, and it's going to be used for setting the QoS profile of my publisher right here. Yeah? Good for now? Questions? Are you following? Something that you don't understand? Makes sense, more or less. I know that there are some concepts that that sound strange, but we are going to be seeing them later, okay? So for now, just get a general idea of the code structure. All right. So yeah, we have reviewed the code for our publisher, and then let's have a look at the subscriber, which is easier, okay? So let's have a look now at the code from our subscriber. Then again, we are importing some things that we need here. We have our subscriber QoS class, which inherits from node. We are initiating this node with the following name. We create a subscriber, which is going to subscribe to the QoS test topic. We have to define the message. We have to specify the message also that we are expecting. We define here a callback for our subscriber, and finally we are setting here directly the QoS profile. Okay, so yeah, here in the publisher we set the QoS profile like this. Okay, we are setting it like this. We have all the settings. We expect to receive all the settings on this QoS profile argument. Okay, then this QoS profile object, we are creating it and configuring it here. All right, as you can see, in this case we are configuring many different things like the reliability, leafliness, deadline, durability, also the depth right here. Okay, so here in the subscriber we are not configuring all that elements, but we are just configuring the depth and the reliability. Okay, the ones that we are not configuring specifically here, they are going to be set to the default values. All right. Then in this case, as you can see, we are specifying the reliability to be reliable. All right, for our subscriber. Then here we have the listener callback, where we are just printing the data received. And we have the main function right here, where we are initiating our node and we are instantiating our class, and then we are just spinning the node forever until somebody kills it. All right, so very simple subscriber code, as you can see. The interesting thing here, the thing to pay attention is this line here. Okay, this is how we are defining the QoS profile here. We are doing it more simple. Yeah, we are just specifying the depth value and the reliability value. Okay, here, as you can see, we are also setting the QoS settings, but we are doing it in a more complex way. In this case, because we want to set different objects, and also we are doing some checks here to make sure to check what is the value that the user is setting the reliability to. Okay, then so let's test it and let's see what happens here, and maybe this is going to give us a better idea of what's going on here. So yeah, let's run this. Then before running, so we are going to start by running the publisher, but before running, we have to make sure that we set our DDS implementation. This is the first line that we are doing here, okay? This export, let me copy it and paste it here. All right, this line, what it's doing is to set the DDS, the DDS implementation that we are going to be using. Yeah, the middleware implementation that we are going to be using, which in this case it's Cyclone DDS. Why I need to specify this? Well, we need to make sure that we are using the same DDS implementation for both nodes. Why? Well, because each DDS implementation has different QoS settings. Okay, then if we want to communicate between two nodes, we have to make sure that both are using the same DDS implementation. Okay, in this case, we are going to be using Cyclone DDS, which is the default one for ROS2 Galactic. Then, yeah, let's set our DDS implementation, and now we are going to run our code with following command. All right, so we are, as you can see, we are running our code, ROS2 run, specify the package, we specify the executable, the node that we want to run, and very important here, we are setting the reliability argument. Yeah, so for our publisher, remember that we have defined this, we have defined this argument, reliability. So we have to set it. Okay, in this case, we are setting it to reliable. Therefore, if we set it to reliable, our QoS policy for reliability is going to be reliable. Okay? Then let me run this and let's see what happens. All right, so I start publishing data, as you can see. Then let's run now our subscriber. So let's open a new shell here. Let's make sure that we source our ROS2 workspace where we have our package that we have just created. Then again, we have to make sure that we are using the correct DDS implementation. And now let's run our subscriber node. In this case, we don't need to specify any argument because we didn't define it, in our node, right? So yeah, here I am running my subscriber and I am reading the data and I am printing it here. All right, so the connection between the two nodes is done properly and they are able to properly share the messages, right? Now, what happens, okay, so let's stop the publisher. Right now I have stopped the publisher. The subscriber, therefore, is going to stop receiving messages, as you can see, because I have stopped my publisher. So what happens now if instead of reliable, I change the reliability policy? Because if we come here to our subscriber code, we are going to see that our subscriber has the reliability policy set to reliable. All right? Then in this first example, our publisher, we were setting it to also have the reliability policy to reliable. But what happens if we change the reliability policy of our publisher to a different one? For instance, best effort. What's going to happen? Let's see. So now, instead of reliable, I'm going to change it to best effort. So what's going to happen now? Let's see. All right. So my publisher starts publishing, but it showed a message here, okay? It says, hey, a subscriber is asking for an incompatible QoS triggered. Okay, so what is this message? Where does this message come from? This message comes from the callback that we have defined in our script. If you remember, here we defined this callback. So what happened here is that an incompatible QoS event has happened. Therefore, my callback has been triggered. So this is why I am seeing this error message in red. Okay? And this is from the publisher side. But if we come to the subscriber, what's going to happen? We cannot see the messages. Yeah? So the messages are being published here from my publisher, as you can see. My publisher node is working, so he is publishing messages, but my subscriber is not receiving them. Why? Well, here we have the reason. So here it says, new publisher discovered on topic QoS test offering incompatible QoS. All right. So then what is happening here? Well, what's happening is that my publisher has one. Let me stop the notes here. So what's happening here is that my publisher, when I have run my publisher, I have set the reliability policy to best effort. Okay? My reliability policy of my publisher has been set to best effort, while my subscriber has a different reliability policy, which is reliable. Then these two policies are not compatible between them. Therefore, an incompatible QoS event is triggered. Okay? And since in my node I have defined a specific callback in case that this event happens, then I get my callback executed. All right? Then you might be asking right now, okay, but and how can I know if two policies are compatible or not, right? All right, then there is a list, a very convenient list, that if you scroll down here in the notebook, you are going to see it. Okay, so this is a list. For instance, if the publisher is best effort and the subscriber is best effort, are they compatible? Yes. If the publisher is best effort and the subscriber is reliable, are they compatible? No. Okay, this is the case that we have just seen right now. where the publisher was best effort and the subscription was reliable. Okay? Then, for instance, vice versa, they are compatible. So if the publisher is reliable and the subscriber is best effort, then yes, they are reliable. Okay? So yeah, here you have a list of all the QoS settings: reliability, durability, deadline, liveliness, and list duration, and if they are compatible or not. Okay, so you can have a look at this. You don't need to learn this by heart, but this is going to be useful for debugging possible issues that might happen while working in ROS2. Okay? Great. Then, okay, so here we have seen an example which is a little bit abstract, right? Because we are just publishing some messages that are meaningless. Then let's see an example with which actually has something to do with the robot. Okay, so we are going to see this incompatibility issue happening on the robot. Okay, this is a very common issue that might happen when working with ROS2. So let me stop here everything. Then, all right. So, yeah. Then here we have a Robotics robot, which is based in ROS2, as I said at the beginning of the class. Then this robot is publishing laser data into a topic. Yeah, in this case, it's publishing laser data into a topic named base scan. So we can check this topic very easily running a ROS2 topic echo command. Let's do it, in fact, right now. So if we run this command, we are going to see what's being published into this base scan topic. And we are going to see that here we have laser messages being published. Okay, as you can see, there you go. Then, okay, but as you already know, if you have worked either in ROS1 or ROS2, this also happened in ROS1. So laser data is much easier and much better to visualize it using RVs, right? Because here we get a bunch of numbers and values which are very hard to interpret. Then let's try to run RVs 2 in this case and try to visualize this laser data that our robot is publishing. All right. Then let me open here a shell of RVs2. We have to set the fixed frame to base link, or base footprint, or also works, okay? And once we have the fixed frame set to base link, we are going to add a visualization element, a laser scan visualization element. This element is used to visualize laser scan readings. So let's add a laser scan element and let's set the topic that we want to visualize, which is base scan, right? The topic is base scan. So let me come here to RVs and set the topic to base scan. All right. So now I would expect to see the laser data, right? But I am seeing nothing. So why is this happening? Okay, so now probably you should know the answer, because it has to do with something that we have just done. Okay, so the correct answer is that there is an incompatibility in the QoS settings of the base scan topic. All right, then the base scan topic is being published by Gazebo in this case, and of course it has some QoS settings. Then these settings are not compatible with the settings that I have right now in my RVs2. Okay? Yeah? Then, okay, so you might be asking right now, and how can I know the settings of this topic, of this base scan topic? Okay, so it's very simple. We can use a command. We can use the ROS2 topic info command, adding the verbose tag here. Yeah, so let's try this. Let's come here to another shell and do a ROS2 topic info of base scan, adding the verbose tag. So if I run it without this verbose tag, this is going to give me basic information related to the base scan topic, right? So it's telling me the type, the publishers, and the subscribers of this topic, right? Now, if I add the verbose tag here, this is going it's going to give me much more information. Between this information, you are going to find the QoS profiles. See? So, all right. So, no, not RVs, sorry, but we want the settings for my topic. Here I have it, okay? So, the QoS setting for my topic is best effort for the reliability, the durability is volatile, the lifespan is this value, deadline is this value, liveliness is set to automatic, and the list duration is set to this value, okay? So here you can see the QoS settings of this base scan topic. Also, down here you have the settings of RVs, yeah, the node that is subscribed to this topic. Then very easily, if you compare them, let me make this bigger, you are going to see where the issue is. Can you see it? Can you see? Can somebody see where the incompatibility is between my base scan node and my RVs node? Between my publisher and my subscriber? ROS2 is reliable, says Leone. Is reliable. The reliability is set to reliable, and in our publisher, the reliability is set to best effort, right? Very well. So what should we do to fix this issue? We should change reliability policy of my RVs node to best effort, right? And how can I do this? Well, here, if we open the options of the topic, you are going to have the possibility to change here the reliability policy. As you can see, right now is reliable, so if we change this to best effort, suddenly the laser readings are going to appear, okay? Let me make them a little bit bigger so that you can visualize them better. Okay, and here they are, okay? So now, once I have set the reliability policy to best effort, now I start receiving the messages. Okay? Very well, very well. Okay, I can see here Jose saying, any idea of why RVs only shows the grid node but not the laser node? Okay, so I think you were asking this. The thing that we have solved right now, right, Jose? Okay. Great. Then, okay, so far, so good. Questions until here? Any question? Something that you don't understand? Or does it make sense? It is okay, says Leone. Okay. Okay, very well. Then let's keep going. Going. So the next thing that we are going to do is to create a subscriber for the scan topic. Okay. Then we are going to create a subscriber which is a little bit more customizable in this case. Okay. So let's create a new Python script here. Copy. Let's create here a new Python script, which we are going to name like this. Subscriber scan QoS.py. Okay, there we go. And then inside this script, we are going to paste the below code. Let me copy directly here from the notebook and paste it here. Okay. Now let's have a quick look at this code, which is this is a subscriber. Okay. Again, as you can see, we are creating here our subscriber for the base scan topic, and in this case, as you can see, I am using a QoS object here that I am expecting to receive whenever I instantiate this class. Okay, so I am now using the same method that I was using before in the publisher. Okay. Let me actually close this publisher and close this. Yeah, so here I have the simple subscriber that I defined previously, where I was setting the QoS profile directly here. So now I am not setting it directly here, but I am expecting to receive this configuration, this QoS profile, from whoever instantiates this class. Okay? So yeah, I am defining my subscriber, and I have the callback for my subscriber, which is very simple. It's just the same. I'm just going to print the messages that I receive in the topic. Okay, nothing strange here. The difference from the regular subscriber is that instead of directly setting here the QoS profile, I'm going to be setting it. I'm not going to set it here. Okay, but I am expecting somebody else, some other function to configure the QoS profile and then receive it here from the constructor argument. All right. Then, so here finishes my class. Then I am creating again a parser function. And in this case, I'm defining many different arguments. Okay. So one argument is history, another is depth, another is reliability. I add another for the durability, lifespan. So basically, I am adding arguments in order to be able to configure and change many different QoS settings. Actually, all of them. Okay, so all the QoS settings are going to be configurable for this subscriber node. Yeah. Then so let me minimize this, and then in my main function, I am going to call this GetParser function, and I am going to, so I am getting all the values, storing all these values into variables, and then I am configuring my QoS profile depending on the values received. Okay, so here I am defining the history, the durability policy, reliability policy, liveliness policy. Okay. So, so basically here I am giving the possibility for the user to set and configure all the QoS settings. Okay? Then we are going to see now, after this example, we are going to go over each of these settings and see what they are for. Okay? So don't worry. Then, so let's compile this. Let's, before compiling, of course, we need to add an executable. So you have the line right here in order to do so. So we are going to open one more time the setup.py file, and we are going to add here another entry down here. All right. So from our new script, which is subscriber scan QoS, we are going to generate a new executable. Then, so let's compile again. Colcon build. There we go. Let's source. And let's make sure, as always, that we set here the proper DDS implementation. And now we are going to run our code. All right, so we are going to run our new node. And this is, if everything is okay, if QoS are compatible, this is going to start printing here all the laser messages. Okay, so great, so far so good. Also at the beginning of the node, if we scroll up here, well, not here, but let me. Okay, so here at the beginning we can see specifically we are printing these are the prints that I have added here, yeah, all these prints. So here we can see all the values that are being used right now. So in this case, as you can see, I have not specified any, right? So if I don't specify any, then this is going to get some default values. For instance, if I don't specify any, if I don't specify a value for history, then it's going to be set to keep last, right? As you can see, history is set to keep last. Then if, let's check the reliability, for instance. If reliability is not set, so it's going to enter the else, then it's going to be set to best effort, right? Then, if I specifically change something, for instance, reliability to reliable. Okay, so now I'm going to specifically specify the reliability argument, yeah, which, remember, I introduced it here in the GetParser function. I am adding this reliability argument, so now I am going to be setting it, all right? So I am going to be setting it to reliable. So if I run my code now, what's going to happen? Well, it happens that I don't get any message, because again, I am triggering the incompatible QoS settings, all right? Okay, then what are all these settings? So all these values, what do they mean? Okay, so let's have a summary of more or less what we have been seeing, and let's try to understand a little bit and have a clearer idea of what all this is. So basically, for QoS, we can define the following policies. We have the history policy, which can be set as keep last or keep all. Okay, for instance, the keep last is going to store up to n samples. So basically, this is going to define how many messages I want to store in my topic. Okay, then if I want to keep all the samples, or if I want to only keep the last X number of messages, for instance, then this is going to be defined also with the depth policy, with the queue size. So here I'm going to be able to define the size of the queue, so how many messages I want to store. Okay, for instance, the reliability, which is the one that we have been using in this open class. This is going to, this has two possibilities. It can be set to best effort or to reliable. For instance, the reliable setting is going to guarantee that samples, that messages, are delivered, even if it has to retry multiple times. Okay, so the reliable policy is going to make sure that all the messages are being published, even if it has to retry multiple times, which at the end it might end up causing some lag in the system, for instance. Okay, so this setting, for instance, would be used for systems which have to, where the messages cannot be lost. Okay, you cannot lose any message. For instance, in the best effort, it's going to try to attempt, it's going to deliver messages, but it's not going to care if some messages are being lost. Okay, so it's going to prioritize speed and that maximum number of messages are sent, and that the rate is maintained, but it's not going to worry if some messages are lost. Okay? This is the reliability policy. We have the durability policy, which has two possible values also, transient, local, and volatile. For instance, for the, let's come down here. This is explained better. The durability is going to regulate whether or not a message published by the publisher stays there forever, so that the subscriber can read it even when they subscribe after the message has been published. Okay? So how long is going to be a message kept there in the topic? Okay? It's going to be maintained there forever, even if no other messages are published or not. Yeah, so if we set it to volatile, then we are not going to maintain that message. And if we set it to transient local, then the last message published into a topic is going to be maintained there. Okay? We have also the deadline policy. Okay? The deadline is the time that we consider as maximum, the maximum time that has to pass between one message publication and the next one to consider the topic being healthy. Okay? So how much time can happen before I start worrying that my publisher is having some issues? Okay? We have the lifespan policy also, which is the time between the publication of the message. So how much time has to we are expecting to have between a message is published, between the publication of a message and the subscriber receiving this message. Okay, so if my publisher publishes a message and the subscriber is not receiving it before 1 second, then hey, you have to start worrying. Okay, so you can configure this kind of stuff. And finally, we have the liveliness and list duration, which basically is going to this is the time that we are expecting our node to publish an alive signal. Okay, so how much time to wait before before we consider a node as dead? Okay. So, yeah, also here you can find the default policies. So if you don't set any of these policies, so this is optional, you cannot specifically set the policies if you don't want to. In that case, they're going to be set to the default values, which are these ones. This is the default QoS configuration. Okay, so yeah, basically that's it. So this is a complex topic, okay? It's hard to try to explain all this into one session of 40 minutes or 45 minutes. So actually you are going to learn all these and about specific policies by practicing and working with ROS2 nodes and having errors and having to solve them and so on. So it's hard to kind of explain all this in one single open class, but I hope that at least you have you got a general idea. Yeah. So yeah, any questions, any comments, anything that you want to say? Or did you get this general picture, this general idea of what this quality of service is? Let me know. It was very instructive. Thank you. You're welcome, Leone. You're welcome. You're welcome also, Jose. Okay, great. Then, yeah, so consider this as an introduction to the QoS settings. And from this point, you can start investigating and practicing more in order to keep learning more, because there are many things to be learned here. And many small details that they are impossible to cover here in one open class. So yeah, as I said at the beginning of the class, you are going to have this rosject in your workspace forever, so you can open it whenever you want in order to review the code, review some specific parts, or even investigate extra stuff from this node. And the last thing I want to say is that we are going to be doing a workshop, okay, at the end of April related to navigation 2. And in this workshop, we are going to be teaching more about quality of service. So we are going to be showing examples of all the different settings, the deadline, lifespan, durability. So we are going to cover this subject much more in depth. And of course, we are going to be covering many other things related to navigation, but also to DDS concepts. So yeah, it's going to be super interesting. You have the link here in the notebook. If you click here, it's going to take you to the workshop page in case that you want to have a look. And if you are interested in the training, so just get into this website and have a look. It's a very instructive workshop. So yeah, that's all from my part. Thanks a lot for being here with me in this open class. I hope that you had a good time and that you've learned something new. And so I'm going to see you next week. Until then, as always, take care and keep pushing your ROS learning. Bye bye.